Are they really the same speed? People often wonder. What if we swing an empty bottle and a full bottle in the same way? Would they share the same final speed? Heavier bottles, in many cases, hit harder. Physics explains this through momentum. Momentum is mass times velocity. If velocity is the same, then greater mass means a stronger impact. But another thought appears. If the same force is applied, wouldn't a heavier bottle end up with a lower speed? One experiment revealed a key detail. A 50-gram object can reach 20 meters per second, about 72 kilometers per hour. A 1 kilogram object is 20 times heavier, yet it still manages around 15 meters per second, about 54 kilometers per hour. That's not half the speed. So if an empty bottle weighs about 500 grams and a full one weighs about 1 kilogram, the full bottle might slow down a bit, but its momentum is far bigger. Thus, it delivers a stronger blow if it hits your head. Even in danger, speed doesn't just halve because of weight. That's another way to phrase it. Of course, this is quite dangerous. Never try it on anyone's head. Curiosity might kill the cat. Safety matters much more. What about a pendulum wave and artificial rain? Here's another physics example. If we hang multiple pendulums of slightly different lengths and set them in motion together, they each have a unique period. That setup is often called a pendulum wave. Imagine one pendulum that completes 60 swings in 60 seconds. Its neighbor completes 61, then another completes 62. After 1 minute, they all return to the starting point. During that minute, they sometimes appear to split into 2 groups, then 3 or 4. They seem to dance like waves. The period depends on the square root of the pendulum's length. The formula isn't too difficult. A little calculation, plus some careful setup, can let you try it at home. As people say, starting is half the job. Now let's talk clouds. Yes, physics applies there too. Artificial rain, known as cloud seeding, involves adding condensation nuclei. Dry ice or silver iodide can encourage tiny droplets to merge. Those droplets then form bigger raindrops. But enough water vapor must be present. A dry sky yields nothing. If you make it rain in one area, you might reduce moisture for another. That raises ethical concerns on a large scale. Stopping rain is even harder. Mid-air evaporation demands immense energy. Today's technology can't handle that effectively. What if Earth spun in the opposite direction? Let's imagine Earth spinning backward. Viewed from above the North Pole, Earth now rotates counterclockwise. If it rotated clockwise instead, scientists say life could still appear. But major winds would flip direction. Trade winds and Westerlies would blow in reverse. Historically, Christopher Columbus relied on trade winds. He sailed from Europe toward the Americas. If those winds blew the other way, his journey would be far tougher. The age of discovery might have been delayed. Schedules might have been entirely different. This shows how simple physics can scale up. It can affect giant topics like artificial rain or planetary rotation. Even the difference between empty and full bottles can spark big what-if ideas. If it seems overwhelming, remember, Rome wasn't built in a day. Step by step, you'll see everything links to everyday life. Stay curious. Science thrives when imagination keeps going.
Knowledge is power.